Hello. Hi everyone. My name is Michelle DePasquale. I'm from DWS. I'm the National Account Manager for the NAB Group. Know quite a few faces out in the audience there, but for some of you who don't know, DWS is a IT services provider. We have 600 consultants nationally, and we have been working with NAB for about 10 years, so one of their partners. And we have about 60 plus consultants working across the group at the moment. And you have the absolute pleasure of one of our senior consultants tonight, Ross Leishman, who's working within asset servicing, to present to you. Ross went off last year. He came to me and said, "I'm really excited. I want to do this training course." And he said to the godfather of data warehousing is going to present, which absolutely, as you can imagine, I'm in sales. I had absolutely no idea what he was talking about. But Ralph Kimball was holding a training course last year, so Ross went along, very inspired when he came out and very excited, and that's why we're here tonight. Ross hopefully this is going to be the first of a series. If you guys are interested and keen and get something out of it, we'll hopefully hold additional sessions. But this is an introduction to dimensional modelling tonight. So we're really keen to get your feedback in the end after the session. Come in. And hopefully Ross's inspiration will feed out to the audience, and you'll get inspired as well. So thank you again for coming out and taking the time out, and NAB's actually giving us this space for this presentation today, so very exciting. So I will hand over to our senior consultant, who I forgot to mention, 20 plus years in the industry and 10 years at DWS, so that's a bit of an achievement. Thanks, Ross.
You didn't take one of my chocolate bars.
Oh, I've got one.
Thanks, Michelle, for those kind words. Excellent. We've got a full room. There's only a few spare seats, a few familiar faces. The likely suspects, down the front there, the fan club, the hecklers over there. So presumably, with such a full room, we're nearing 120. Everyone here is really excited about data warehousing. Everyone heard of Ralph Kimball, the godfather of data warehousing, excited about it, wants to know more about what Ralph thinks? Yeah, so presumably the rest of you are here to heckle me. Right. It's not exclusive, yes, you can probably do both. All right. A couple of administration things. This venue, the Bowl at the Academy, thank you very much to NAB for providing us with this magnificent venue. We've got half NAB people and half DWS people. We're equally represented, and it was very generous of NAB to provide the venue. So thank you very much. The presentation will go for 90 minutes. We're currently nearing on 5:30. My trial run of this presentation lasted 2 hours, but I have trimmed it a little bit. So I'm hoping to stick to 90 minutes. 7 o'clock will be my intended finish time, and we'll take sort of extended questions after that if you want to stay back. You can also ask questions as we go. I'll talk more about that in a minute. Okay, rules of engagement. Now, I heard an excellent term last week. It was death by PowerPoint. Who's heard of death by PowerPoint before? Who can imagine what death by PowerPoint is? No hands. Okay, right. Excellent.
That's because we lived it.
You've all survived, so it can't have been too bad. Right, death by PowerPoint. Now, studies show that the leading cause of death by PowerPoint is buzzwords. What's the biggest buzzword for presentations? What word do you hate to hear in a presentation over and over and over again?
Slide.
No, not slide. Basically is the word that you hate to hear over and over again. So my promise to you tonight is I'm not going to say the word basically. Has anyone else got any other buzzwords I don't want to hear? Smart Alex over there, you'd not apply. ETL, yeah. Right. Who was that? Kev? No? Right. The other one that I hate is literally. Is Jamie Oliver. Who watches Jamie Oliver's cooking shows? Literally? He literally says literally every 2 minutes, I reckon. So that's the last time you'll hear basically or literally from my mouth. The other leading cause of death by PowerPoint is reading the slides. So I've been given 2 challenges tonight by Tim Redrup. Tim's not here yet, is he? He's going to be late tonight. No. Tim gave me 2 excellent pieces of advice before he started. He said, don't use basically, which I've already told you about. Another one is don't read the slides. So I'm going to attempt to do that. And if you catch me saying basically, literally, or reading the slides, you get a prize. So stick your hand up, ping me when you hear me do any of those things. I'm not going to say those words again. All right. And the other thing that I'll do is, as we take questions as we're going along, I've got 15 boost bars because Michelle took one. 15 boost bars here. I'll hand out prizes for questions that come along as we go. But to keep it interesting, your question, if you want a boost bar, must include the name of one of the 7 dwarfs. Okay? So give it a
remind us who they are.
If you don't know who they are, then I'm not helping you earn a chocolate bar. Right? If you want to ask a question without naming a dwarf, that's okay, but you won't get a boost bar. Okay, so as Michelle said, I went along to see Ralph Kimball's training course, to participate in Ralph Kimball's training course last year. This book is not actually the book that the training course was based on. The one I did was ETL Architecture. But in order to appreciate ETL Architecture, you first must appreciate dimensional modelling. So this presentation is a lead-in, if you like, to the further presentations, which will be on ETL Architecture. So it sets the foundation knowledge that you'll need to understand those presentations if you'd like to come to them. So dimensional modelling, this book, The Data Warehouse Toolkit by Ralph Kimball and Margie Ross, edition 2, you'll see lots of references to this book in the slide pack, because the slide pack is, and this presentation is unashamedly based on the book. Okay, so I'm not presenting my views of dimensional modelling, although you will hear a few of those as we go along. I'll preface my views by telling you they're my views. Most of the rest of them will be those of Ralph and Margie. If you want to get a hold of that book, I wanted to bring along a hard copy for you. I only have a soft copy of it, and I tried to get one in Melbourne at lunchtime today, and I couldn't. So hit up.
All you have to do is ask.
Oh yeah, hit up Amazon if you want a Kindle or a hard copy of the Data Warehouse Toolkit. Money well spent. Righto, agenda tonight. You'll find out what I talk about, so I'll go through it really quickly. Talking about what is a data warehouse. Oh, but not read this slide. Someone will get me. So, why we have data warehouses? Why they're different to other types of systems? What comprises a data warehouse? What are the individual components? Ralph talks about. He's very passionate about the presentation area, one of the components of the data warehouse, and he's got many 3s and 4s. He's got 3 slowly changed dimensions, 4-step dimensional design approach. He's got 3. He just called them rules. I called them axioms. So I'm promoting them up a little bit. 3 axioms of presentation area design. I'll go through those, as well as the approach to dimensional design. So designing a dimensional model, and no summary or introduction to dimensional modelling would be complete without slowly changing dimensions. That will get you to ground zero of data warehousing and dimensional modelling. If you're still interested and you want to know more, then go buy the book, because there's plenty more in the book. This covers about the first 1.5 chapters, I'd say. Probably the first 30 pages of several hundred. All right. Okay. Now you may catch me reading the header slides. Okay, you're not getting a boost bar for that. What is a data warehouse? Right, so in Ralph's world, there's two types of systems. Operational systems of record.
Why are the operational system users not happy?
You're testing me. Okay. Now, this is an occupational health and safety moment. Getting this to Matt. So the people in between Matt and I are good catches, yeah? Thank you. Operational system users are not happy because this is a presentation about data warehouses. And I was going to make a prediction that happy would be the first dwarf name used, and I was going to award myself a boost bar for this, but I'm betting there'll be some left over because you guys don't look like the sort that will claim them, except Matt. All right. Operational systems of record. These are the sorts of systems that we're all familiar with. They're the systems on which we do business. Okay, we enter transactions, we enter sales and invoices into these systems. We enter we consultants enter our timesheets into these operational systems of record. They're the systems that on which we conduct our business. Data warehouse is different. A data warehouse does not conduct any of our business. All it does is feeds off the operational systems of record. It collects all of the data from those other systems on which we conduct our business and presents that data in a way that it can be analysed for decision making. And of course, data warehouse users are happy people because they don't have to run the business, they just have to watch it. Okay, so difference between operational systems users and data warehouse users. Operational systems users, like I said, they run the business. What they tend to do is, so say you're taking sales. Okay, you're a salesperson. You're entering individual sale by sale into the sales system, taking orders. If you're a consultant, like half of this room, you're entering timesheets day by day into the timesheet system. You tend to be using small amounts of data at a time and doing repetitive tasks and predictable tasks. If you're a data warehouse user, then your behaviour is a little bit different. You never really deal with one record at a time like those operational systems users. You're dealing with large volumes of data at a time. You're looking at trends in data over months or years of time and over the entire enterprise. So the other thing about data warehouse users is not only do they deal with large amounts of data, they ask different types of questions all the time. The way they use the data is not predictable because in a data warehouse, we're trying to... a data warehouse is otherwise known as a decision support system. Okay? We want to make a decision. We want to look at our data to support that. Well, I want to know whether I should sell more widgets in the northern region, or how many widgets am I currently selling in the northern region compared to other regions. So, so I ask these questions. Then once I've answered them, I'm unlikely to ask that question again. I'll go ask a different question. So our needs change from day to day in a data warehouse, very much unlike an operational system where we ask the same questions every day. So leads us to Ralph's first law of data warehousing. I don't think he quite termed it like that. I may have embellished again. So if data warehouses work differently to operational source systems, data warehouse users have different needs to operational source system users' needs, then surely it's not too much of a leap to suggest that the design of these systems needs to be different to support those different needs. Or as Rolf puts it, a database copy of an operational system of record is not a data warehouse. Who's actually seen that happen? Is take a source system, replicate it, call it a data warehouse, and run all of your decision support off that. Yeah, a few people. I've seen that as well. So we'll get to that. If you if you try to call your operational source system a data warehouse and try to do what you do in a data warehouse off such a system, you'll come badly unstuck. Right. So an illustration of that point, because it's a point that's that's difficult to accept for a lot of people. Well, in my operational source system, all the data's there. It's a computer. Surely it can come up with the answers that I ask. Right? So then you can have as many Ralph Kimballs as you like walk up to you and say, well, no, that's not true. But it's still very hard for people to accept. As an exercise, I'll explain by analogy, perhaps. So, warning, I'm going to read this, so no boost bar for this one. The Luddite Insurance Corporation has not computerised its records. Individual policy and policyholder information is captured on policy application forms and stored in filing cabinets, indexed by surname and expiry month. So I open a policy to insure my house and contents with Luddite. My form goes into a filing cabinet. Its renewal date is December 2013, so that's where it goes in the filing cabinet under Alpha Leishman. So what types of client queries could this database answer? The database that is a filing cabinet. What sort of question could you ask that database could answer?
Depends how much time you've got.
Well, just what about simple client queries? A client rings up and asks, I've forgotten my policy number. Well, no. What's your name? So, well, what's your name and when did you take out the insurance policy? We could look that up. Okay, so a nice easy one. Any other sorts of questions it could answer?
Yeah, they can answer when the policy is going to expire.
When the policy is going to expire, yeah, give us your name. We could look through the next 12 months, look under L for January, L for February, yeah, that's not too bad, we could work that out. So the sorts of questions that this database could answer are operational questions, individual pieces of information, so just single points, if you like. What about management queries? What if one of the risk managers of Luddite were to ask the question, what's our total exposure? So how many houses do we have insured and what's the total value of them? What if they want to know the total exposure by region? How would the database cope with that? Depends on how many
Graduates you've got.
Depends on how many graduates you've got. Right. So you could answer the question, but you'd have to remove every file from that filing cabinet to answer it. Okay? So it's a matter of time. So is the question answerable? Yes, the question is answerable. Is it answerable practically? So when a manager asks a question like that, what's our total exposure for the northern region, do we think he's going to want the answer in 3 months' time, which is how long it will take us to find it? Right? So by analogy, this is exactly the same way, it's exactly the same as the difference between operational source systems and data warehouses. There are particular types of questions that operational source systems are good at answering. Right? And there's particular types of questions that they're not good at answering. All right.
Is there a difference within data warehousing and business intelligence?
Any other words you'd like? No. So there's no boost bar for you. Is there a question? Is there a difference between business intelligence and data warehousing? No, not really. Business intelligence, in my opinion, is a newer term than data warehousing. It's a term that in my opinion has replaced or is replacing data warehousing, and data warehousing is the term that, or a data warehouse is the term that is replacing or has replaced decision support system. So it's just new way of saying old things. Okay, good. So this is one of Ralph Kimball's favourite bits. his consultancy, their business model is go into a business for a few weeks, charge exorbitant rates, of course, and answer some very high-level questions, and then leave again. And what he finds with every organisation he goes into that wants to talk to him about data warehousing, regardless of the organisation, regardless of the industry that they're working in, is that they all want roughly the same thing from their data warehouse. Clearly the data itself differs from organisation to organisation, but the high-level goals tend to be the same. So if we've got these universal themes that apply to all data warehouses, then it's reasonable that we would have some universal requirements. Yes, we'll have individual requirements about individual business processes that occur in each organisation. We'll have individual requirements about for individual organisations, but these universal themes lead to universal requirements. I'll go through each of these 6 universal requirements one by one. Accessibility is the big one. This covers a lot of ground. It's you might think accessibility. It's just get the data to the user, but the Luddite Corporation got their data to the user by putting the filing cabinet in a public place in the office. Everyone could get to it. So clearly accessibility is not all it's cracked up to be. So it's not enough for the data to be simply available. It also needs to be understandable and intuitive. So who here works on or has worked on what I'm calling an operational source system of record, the sorts of systems that we enter sales into and invoices and things like that? Yeah, lots of people have worked on those. Who's familiar with a data model for one of those systems, or got into a SQL database and had a look at the list of tables that are available? How many tables would we normally find in such a system? Is it less than 50? Is it 50 to 100? 100 to 200? Over 200? Yeah. Sometimes over 300, sometimes over 400. That's completely consistent with my experience. So how would a user go if, in order to answer their questions that they have about extracting data from the database, we gave them access to a SQL client that presented them with 300 or 400 tables? Do we think they'd be able to answer their questions? Do we think the data is accessible? Okay, it's available, right? But is it understandable and intuitive? If you're presented with 300 or 400 tables, can you possibly have any idea what's going on unless you've spent a couple of years working with this system and understand it?
Understand business rules.
Yeah, right. So, so it needs to be available, understandable, intuitive. It needs to be labelled meaningfully, and it needs to be labelled in business terminology. Those people that have had access to these SQL clients where they can see their 300 or 400 tables, how many of those table names and those column names have meaningful business names, the same names, unabbreviated, that the business use in their day-to-day use? Okay, they tend not to. Right? They tend to have lots of technical names in there. They tend to have lots of abbreviations in there. Okay, and apart from all that, and this is where the Luddite Corporation fell down with their filing cabinet database, it needs to be fast. Okay, and that all of those things go into accessibility. Okay, consistency, and this is one that we tend not to notice. A lot of the work that I do tends to be focused on individual business units, but that's not what we're really talking about with data warehouse. We're talking about collecting data for the enterprise. Imagine if you were collecting data from the ordering system and you're collecting data from the delivery system or the warehouse system, and the the orders system defined a customer's address as the billing address. That would be logical. They're taking the order and they're billing at this address. The warehousing system defined a customer as the delivery address because, hey, they don't care where it's billed to. That's not their problem. They've got to deliver it. Okay. Now, if you asked, if a manager asked a question, how much of product X do I ship? Then, well, ship is probably a bad word. How much of product X have I moved? Then the source system might say, well, we've sold 10,000 units in the last month of product X to the northern region, and the warehouse. Actually, warehouse is a bad term because I'm talking data warehouse. Steve's nodding. He goes, oh yeah, Ross has just caught up. Thought of that 5 minutes ago. When I say warehouse there, I mean the warehouse with the spiky roof, sort of. So somewhere that's shipping product. The deliveries, the person for the delivery system, 10,000. We actually shipped 11,000 units of that product to the northern region. Okay, you've got two different groups in the organisation claiming two different figures for the same question by a manager, and this drives managers nuts. And it might not be because the data is different. It might not be because of an error, because of orders that didn't get through to delivery. Could just be some definition, like the sales definition of customer versus the deliveries definition of customer. Right, so consistency. It's important for us to consistently define data across the organisation, have the same definition of customer across the organisation, have the same definition of product across the organisation. Right, adaptability. Now, with an operational source system, we build operational source systems, and then we tend to just leave them there. Nothing much changes. We take orders today in much the same way that we did a year ago or 2 years ago. The systems don't change that much. Yeah, sure. Sometimes there's enhancements or regulatory requirements that we have to meet, but things aren't changing that much. With data warehouses, it's very different. Like I said before about decisions by their very nature change. We tend not to make the same decision twice. Once we've asked a question and answered it, it's not interesting anymore. We want to ask a new question. And for this reason, data warehouses, by that nature, will change all the time. We'll want to ask different things of our data warehouse all the time. Once we've discovered something about our data, we'll want to know something more. It'll tell us some fact and we'll know, well, why is that the case? Often what will happen is we don't have the data to answer that second or third or fourth question, and we'll have to go and get it, right? Which means the data warehouse is going to change. So when we build a data warehouse, we expect this to happen as a matter of course, as a matter of the normal business practice of data warehousing, that it will change, therefore it must be resilient to change. Security. We all know about security, normal role-based security. I'm not allowed to see what I'm not allowed to see. Data warehouses have one extra security problem that never occurred to me until I worked for one of DWS's clients, where they pointed it out. We were accepting a data feed from the general ledger system. All we wanted was we didn't want the entire general ledger from the system. We just wanted a small subset of it, just for one business unit. Right, but their data extract. Look, we don't want to give you some special data extract because we've already got the full one. Right? But so why would we want to create a second one just for you? That's extra time and effort. We've already got so much to do overnight. But then security stepped in and they said, if you give them the entire general ledger extract every night, then they can predict the company profit days before it's announced on the share market. All right. That's a security issue. Right? So data warehouses they don't just operate in the isolation of a single business unit. They operate across the entire enterprise, and that gives them access to data that line by line is not necessarily sensitive, but in its entirety can be very sensitive. All right, decision support. All right, how many people here have worked on data warehouses before? How many of you would say that those systems have been purely about decision support? Right, okay. So, and this is a funny thing, is Ralph Kimball gets very wound up about data warehouses only supporting analytics, only supporting decisions, and one of the quotes in the book is the true output of a data warehouse of the decisions that are made after the data warehouse has presented its evidence. I can't say I completely agree with it, because we do use data warehouses for a lot of other things. We use them for management reporting, sometimes, so like monthly management reporting. We use them for offloading overnight operational reporting from our operational source systems. We use them for just general user queries of individual lines of data. These are sort of familiar things to the data warehousing people in the audience. We do all these things on our data warehouses. Yeah. So, and in fact, I think it's. I'm going to make almost the reverse point to the one that Ralph and Margie are making in the book about decision support. Is in my experience, a lot of the funding for a data warehouse comes from these other sources. We need something to do our management reporting. We need something to do this. We need to offload some of our reporting load from our operational source system. So when we're building our data warehouse to support these funded requirements, we still have to keep in mind that there is decision support out there. We're not just about answering predictable questions month after month after month. If we're doing our job right, we'll create something that is also truly a decision support system. All right, lastly, acceptance. Unlike an operational source system, where in an operational source system, users have to use it. Okay? If the order doesn't go into the ordering system, it won't get through to dispatch, and the customer won't get their product. Right? You have to use operational source systems. There's no way around it. You can build the greatest pile of rubbish in an operational source system. People will complain bitterly, but they'll still use it. It's not true of a data warehouse. Okay? If they can't get their information from a data warehouse, they'll either get it from somewhere else, or they'll make decisions without the data, on gut. Okay? If, after you've delivered the finest example of a data warehouse in human history, it's still not being used within, say, 6 months of delivery, you've failed. Okay? The data warehouse must be accepted by the user community in order for it to be classed as a success. All right, structure of a data warehouse. Restaurant analogy. Who's heard of the restaurant analogy? Yeah, a couple of people. Not many. Okay. Ralph loves this one. Okay. And keeps on coming back to it. I won't come back to it many times, right? But I would be remiss not to talk about it. A data warehouse is like a restaurant. So you can see on the slide there, we've got a data warehouse on the top, restaurant on the bottom. So a data warehouse has source systems that supply data. A restaurant has suppliers that deliver it raw food products. Okay, data warehouse has what we call a staging area, which is analogous to the kitchen of the restaurant. In the kitchen, we accept the raw food materials and turn them into meals. Okay, those meals go to the dining room, where we will find customers. And in the data warehouse, the dining room is the presentation area, and that's where we find our users. All right. So I'll go through those, particularly those two areas, the staging and presentation, in the following slides. All right, staging area, the kitchen. I'm going to get sick of saying kitchen. All right. So the staging area. This is part of the problem of talking about the data warehousing according to Kimball. Is there are some terms that Ralph Kimball made up and popularised in the first edition of the book that I spoke of earlier, and some of those terms are well defined across the industry. Others are kind of not so well defined, possibly because Ralph didn't make them up, or possibly because they were stolen from and used in different contexts. Staging, I find, is one of those things. In various different projects I've worked on, staging has meant a different thing, but it means something very specific when you're reading the Data Warehouse Toolkit. So from the time that we accept data from the operational source system, and we acquire that data, to the time we present it in the presentation area to the users, everything in between those two, everything between those two is staging. Now that includes the raw data that we acquire, the ETL software. Everyone heard of ETL here? Yeah, a few nods. Yeah, good. We'll get to ETL in a minute. The ETL software that extracts, transforms and loads that data, and any persistent storage of data that is not presenting data to the users. Okay, sort of back office stuff. We want to persistently store a lot of our data. So all of that is staging, and that's not a definition that's that familiar to me. Typically, I wouldn't call the ETL software part of the staging system. But for the rest of this presentation, that is what staging is. It's the raw source data that we've acquired, the ETL software, and the persistent stage data. Right? So all of these things happen in the kitchen of the data warehouse. And Ralph's favourite analogy for the kitchen is that customers never come into the kitchen. Okay, kitchen's full of sharp things and hot things. Okay, our diners might hurt themselves in the kitchen. The kitchen's a dangerous place if you're not a trained professional. Okay, they might hurt the kitchen. That's actually a very good point. Okay, which is why we don't allow waiters in the kitchen either. Right, so. No dwarf name there, Andy? No? Okay, good. So we don't allow customers into the kitchen. Customers stay in the dining room where they're nice and safe and they only eat what we give them. All right. So I said ETL, extraction, transformation and loading before. So I'll just check how we're going for time. Right. The extraction process, not much I can say about that, so let's not spend too much on the slide. We've got an operational source system. It has data that we want. We need to extract it. The only thing that I'm going to say about this is operational source systems have priorities beyond the data warehouse. In the list of relative priorities of an operational source system, data warehouse is right down at the bottom. They don't care about us. Okay. As a software designer for extractions, we often find that our operational source systems are database systems, SQL database systems, and we extract the data using SQL. SQL is an enormously powerful language. We can do a lot of things with SQL. While we're extracting that data, we can go, oh, actually we need to convert that to a character and prepend some zeros to it. We need to concatenate these two names together for our data warehouse. All these transformation type things we could actually do when we extract. We save ourselves an awful lot of work in the staging layer when we're loading. So where should we do this work? Should we do it in the extraction layer or should we do it in the transformation layer? Good, I'm getting a nice shake of the head from Andrew over there. Fantastic. Still no dwarves. There's no shaky. Right. Like I said, data warehouse priorities for source systems, very, very low. Keep it simple. Just extract the data into whatever interface mechanism you're going to use, whether it be file or XML or a message queue, to get it into the data warehouse. Do your transformations there, okay? Because if something goes wrong, or you want to change something, or there's some finger pointing to be done because the operational source system can't meet their overnight batch windows, the first place they're going to look is the data warehouse. So if you've got a nice simple select star from table in the extraction, then you're gold. All right, transformation. So we've got this raw data from the operational source system. We've already said before that we don't want to build a copy of the operational source system because that wouldn't be a data warehouse. Right? Because data warehouse users do things differently to operational source system users. So what we're going to do to this data is not simply pump it straight into our data warehouse. We're going to change it in some ways. Right? And those changes we call transformations. So the sorts of things that we might do in our transformations are cleansing of the data. Jeff Bowles not here, is he? No. Jeff and I will get into animated arguments about cleansing. Jeff's an anti-cleanser. That's okay. If you do decide to cleanse your data in the data warehouse, the right place to do it is in the transformation layer. So the sort of things that we're looking at there, the most common cleansings are address cleansing. When most of the operational source systems that we're familiar with were created, addresses were just free-form text. Right? We now have the ability through databases that Australia Post give us to individually identify addressees down to like unit numbers and lot numbers and street numbers, things like that. So we can do a lot with address parsing and cleansing. If there's the avenue is spelt wrong, or there's a comma missing from the address, we can clean all those things up. And if we choose to do that, Jeff, the absent one, then in the transformation component of our data warehouse, that's a good time to do it. Combining multiple sources. The best example of this that I've got is we've got an orders system that's got customer data in it. What sort of customer data might the orders system be interested in? Well, customer name, customer address. That's about it, not much else. What information about the customer might the data warehouse be interested in? Well, they might be interested in a whole lot more stuff. They might be interested in regional information, market segment information. There might be all sorts of marketing information about this customer that we might want to know in order to direct promotions to them. So we've probably got a marketing division in our organisation that has a whole other database on customer, right, that is not part of the ordering system. So we go to the marketing system, we get all their customer information. We go to the ordering system, get all their customer information. We've got to put it together somehow. Right? That happens in the transformation layer.
Ross, does Kimball's doc cover where the corrected misspellings distort the matching data from the operational system?
Sorry, could you repeat the first part of that, Murray?
Does Kimball's doc?
Right.
Thank you.
Sorry, I was actually only listening to the first part of that. Could you repeat it? Does
wait,
Kimball's document or book...
For example, address correction or postcode correction, transforming, say, half of Corio into South Lara.
Right. He doesn't get into specifics like that. What he's more interested in is what types of transformations you're going to perform and where you perform them, and that is in the staging layer. Right. Deduplication speaks for itself, and assigning warehouse keys. You'll see a little bit more of this later. In our data warehouse, every line of data that we receive in, we're not going to trust the the key that the source system has provided us to stay the same, we're going to assign it a brand new numeric key of our own, something that we don't publish outside of the data warehouse, something that we use internally for tracking. All of the data that we get in, we're going to assign one of these keys. Who can tell me what that's called? Surrogate key. Matt was going to make it a sneezy surrogate key, were you, Matt?
You're just making me grumpy.
It's not a question.
Just a statement of fact.
Right. So Tim's shaking his head here because he's got no idea what we're talking about. Explain later. Right. Loading the presentation area. So after we've done all of our extraction from the source systems, our transformation of that source system data, we want to load the presentation area. Historically, we would do this in a bulk operation. The source system has had all day to capture its data from hundreds of concurrent users. Okay, so it's a highly parallelized operation. It's ambitious to think that we could take all of that data and direct it through one single streamed program into the data warehouse in the same way that it wouldn't happen in the same way that you couldn't get all of that source system data entered by one user. Okay, so we tend to use in an overnight ETL, we tend to use bulk data loading methods. So those of you familiar with databases, no, there's got to be in a question.
What happens? What does it say about real-time database?
I'll get to that. Okay. So what we do is overnight, we'll do things like drop all of our indexes, perhaps. This could vary from system to system, but examples, drop all of our indexes, use bulk loading methods to pump as much data as we can in at once using parallel loads, things that we can't do while the database is up for query mode. And then once all our data is loaded, we will switch our indexes back on, and lastly, we'll notify the user community when we allow users back into the presentation area. We notify them what we've done and when it's available. Good question.
So are you saying, Ross, that data warehouses are really only good for backward-looking data and that they're not good for real-time use?
Right. So two questions on real time, which is interesting because that seems to be the real trend in data warehousing at the moment, and the data warehouse toolkit is actually the second edition is a little bit old. It was a little bit behind this trend towards real time data, and it doesn't, in my opinion, it doesn't address it adequately, because the last two projects I've been on with DWS have both wanted real-time data in the data warehouse, and our traditional methods of bulk loading data overnight are simply not appropriate for real-time data, because if we drop all of our indexes while our users are trying to get data out of it, then the user experience is going to degrade. Okay. Also, while we're loading data into the system, we'll have transactionally inconsistent data. So if we've loaded one part of a transaction but not the other part of a transaction, then you'll get differing results for users that are running queries in real time while we're loading data. As a presentation on Ralph Kimball's thoughts on data warehousing, I don't have a good answer for you. So, reverting to my own thoughts about data warehousing and the projects that I've been involved in that have requested real-time data loading into the data warehouse, the only way that I can see to do it is to replicate what happens in the operational source systems. In operational source systems, we've got dozens or hundreds of users putting in transaction by transaction. Okay, when an operational source system user creates a transaction, they create all components of the transaction. They'll create the invoice and the invoice lines before they commit, so it's transactionally consistent. you won't see an invoice header without the invoice lines. You won't see 5 of the 8 invoice lines committed. Okay, so we need to design an ETL process that mimics that approach. Okay, so why would that work for a real-time ETL when it never worked for an overnight ETL? And the key to that is when we're performing ETL in real time, we've got a 24-hour ETL window. Okay, overnight we might only have a 4 or an 8-hour window. In one client I worked for, we had a 2-hour ETL window. We had to get effectively 24 hours of data, or if you look at it realistically, a business day across the country is probably a 12-hour business day. We had to get 12 hours of data into the data warehouse in 2 hours or 4 hours. Okay, and that usually requires bulk loading methods. But real time, we just have to get it in as it arrives. So if there's 100 users entering data in real time in the operational source system, then we need to design our data warehouse to have that degree of parallelism, that style parallelism. Maybe not 100 users, because our machines can enter data quicker than a user. But we need to apply parallelism to it, and we need to do it all day.
So, Ross, just on that point though, you're really at the mercy of the source system and the controls that source system has. Because if the users are able to enter in transactions that aren't fully committed or whatever, then the real-time data store brings across. Yeah,
and interesting you should bring that up. It means you've been listening when when this has come up in the project. Thank you, David. And sorry, was there you arrived late, so you don't know about the buzzwords.
Oh.
So that's okay. You don't get a chocolate bar. So yes, that's right. And that's one of the topics, more advanced topics for one of the coming lecture series. But yes, we need when an operational source system creates a transaction that might involve multiple records in multiple tables, then we are at their mercy to tell us what comprises a transaction so that we can replicate that in our ETL. Okay, if we can't put the transaction back, if we can't put Humpty back together again, right, then we will necessarily have transactional inconsistency, albeit briefly, in our data warehouse. Okay, structure of the staging area. At this point in my slide pack, before I reduced it to try and meet time, I'm just having a look at how we're going here. Not too bad. I had a picture of Ralph Kimball and Bill Inman. Who's heard of Bill Inman? A couple of hands. Yeah, there's a few data warehousing people here. Bill Inman is Ralph's mortal enemy. If Bill says black, Ralph says white. They've mellowed a little bit over the years, and they're starting to see some common ground. It's actually a little bit scary. In Ralph Kimball's world, version 1 of his data warehousing toolkit book, he described and the subject of this lecture, dimensional modelling, he described a data warehouse where all of the tables in that data warehouse were dimensionally modelled. He had no room for a normalised data model. A normalised data model is the sort of data model we use in those operational source systems. They're data models that are designed for answering the types of questions that we have in operational source systems. So, Ralph, very, very anti a normalised model in the data warehouse, and I'll get to that in coming slides. However, the world decided not to follow his advice on this, and a great many data warehouse practitioners could not follow that approach. That yes, Ralph, we agree that users should be accessing data in dimensional models, but really to get all our ducks in a row, first of all we need to acquire our data, place it in a normalised model so that we understand it fully, and from there we'll build the dimensional models. Ralph is slowly coming around to this way of thinking. So his and this normalised model, this is the Bill Inman approach. Bill, I think he's probably coming around too. He said, forget the whole dimensional model thing. What you need is a great big normalised enterprise model. So we take our normalised models from all of our operational source systems, we put them together in one normalised model as if we had one system, one operational source system that covered our entire enterprise end to end. Right, and this is our data warehouse, says Bill. So a lot of data warehouse professionals out there, they decided, well, hybrid approach. What we'll do, we'll take our data, we'll put it into an enterprise model, but we won't let the users into that. We'll transform it yet again into dimensional models. This is quite a popular approach. I'm not saying it's the right approach, but it's a popular one. So what Ralph says now is, well, your staging area needs to persist all of that data that you acquire, okay? And the format that you persist that data in must be a readily accessible format. And by readily accessible format, he defines three in the book, being flat file, XML, and database tables. Okay? So I acquire the source data from the source system, I load it up into a table in a database in the staging area of the database, and if I don't delete it, then that meets the Ralph Kimball minimum requirement for persisting data in an accessible form. However, it's also possible to persist that data in a fully normalised structure. If you choose to do that, you're still meeting the Kimball definition of a staging area. It's in relational tables, which are readily accessible. If we don't delete from it, then it's persistent. So that's great. So Ralph says now he's coming closer to the meeting point with Bill Inman. Says if you want, I'll get to it in a moment, Matt. If you want to do this, you're free to do it, but don't let your users see it. Your users only see the presentation layer. Matt?
I was just going to ask a question around about XML as a form of persistence. It seems to me that that's a bit dopey.
I'm not completely on board with the XML thing, nor am I completely on board with the flat file method. I much prefer a relational table. I find them personally. I find them much more recoverable, if you like, in the event of issues. If we get to the point that we actually need this old data, if something goes wrong in our presentation system, we need to re-transform it. I don't want to be going back to XML. I don't want to be going back to flat files. Okay, I'd like it all in relational tables. Ralph's just not as prescriptive as me. So he says XML's fine. It's readily accessible as long as you don't delete it. It's persistent, therefore good. But I do tend to agree with you. Was there there wasn't?
I didn't say it strikes me as dopey.
Oh, that's okay. So OHS moment again. Here we go. People in the middle, please catch.
It's up to the rest of you to get my shot.
All right, I've still got one.
I can see why he would say that, because if you discover that there's errors in your data model, then to go back to something approximating a source would mean that you could resolve those errors and then reload.
You could resolve the errors without revisiting the source system.
Yeah.
Yep.
Whereas if you're already storing it into a relational set of tables, you're all the way down the path of having consumed that data and therefore made all of your assumptions about the design.
Okay, that's actually a good point. So if your persistent store is a normalised data model, then you've probably done at least some of your transformation before you've gotten there. Okay, what if you've made an error in that transformation? And for that reason, some architectures will dictate multiple points of persistence. Okay, we keep a persistent store of the source data in flat files, and we persist a normalised enterprise layer, if you like. That's valid as well. So as a data warehouse architect, you can apply a lot more layers of rules, if you like, but Kimball is just laying out a foundation. Keep a persistent source, keep it accessible, And one of the lessons there is what he defines inaccessible sources such as COBOL copybooks. Yeah, look, it might be accessible to COBOL, but not readily accessible to the average ETL tool out there on the market. Right. So this is his last word on normalising the staging area. He gets a lot of questions and a lot of excitement on this because a lot of data warehouse people out there have created data warehouses where they've normalised an enterprise layer before they've presented in dimensional models. It's a long statement, so I won't read it to you lest I lose all of my remaining boost bars for violating Rule 2. But I'll leave it up there for just a minute so that you can read it yourself.
Hey Ross, does this sort of rule really imply a limit on the technical skill set of your end users?
Was there a dwarf in there? No. Okay, good. Right. Does the rule? Okay. So in the Bill Inman world, we would present the normalised model to the user. In this point, I agree with Kimball. The average normalised model extends to hundreds of tables, and it's unsuitable for presentation to the user. So if you're creating the normalised model in your staging layer, then it's completely invisible to your user. Right? You're presenting to them dimensional models, which I haven't described yet, and we'll get to. So this decision is purely a technical one. It doesn't involve the users. Okay. Presentation area. I promise we'll talk about dimensional models very soon. All right, so the presentation area. This is the dining room of our restaurant. This is where beautiful meals are served up to our diners. All right. So everything we've done to date has been completely invisible to our user community. They haven't seen all of the transformations that we've performed. They haven't seen the raw files that we've acquired. They haven't seen the possibly normalised layer that we've persisted our data in. All they get to see is the dimensional data that I'll describe in the coming slides. Last one is an interesting one, and goes to Andrew's question a moment ago. As far as a user is concerned, this entire restaurant consists only of a dining room. They're not aware of the kitchen, the staging area, all of the things that we do in the back room because we don't show them that. And Andrew's about to get stuck into me about metadata. Is he? No? Okay, all right. We'll take this up offline. Right, so dining room is where the action happens as far as the user is concerned. So organising the presentation area. The presentation area is comprised of what Kimball calls data marts. And it might not be if you've heard the term data mart used before, not in a Kimball context, might not be what you know as data marts. So there's a nice example of what we could be talking about as data marts. We've got three source systems there, the HR system, the orders system, and the deliveries system. And we want to present data marts that define a business process in our organisation. So if that business process involves salaries, then the only information we're going to want to query in there comes from the HR system. Similarly, we could want to query sales or logistics, and that would be single source system data marts. Equivalently, we might want to know about commissions. Okay, we might have salespeople and the sales that they make. Right? So the information about the salespeople is in the HR system. The information about the orders that they take is in the orders system. We want to combine this data into a single queryable structure called a data mart and present that for queries based on commissions. Similarly, fulfillment. What orders have we taken and have they been delivered? When were they delivered? Where were they delivered? Okay. We would combine data from the orders and delivery system together in a single structure that we might call fulfillment. Then you might have profitability. Every organisation has profitability, and you're probably going to get every single source system involved together and presented in a single data mart in the presentation layer. So depending on the business process that we're looking at, we might have several data marts in our presentation layer. All right. Ralph's 3 axioms, he just said rules, of presentation area design. Okay, number 1, presentation area must be dimensionally modelled. Do I keep on promising that I'm going to get to that? I will. And it'll be in the very next slide. Number 2, the presentation area. Am I reading the slide? No one's claimed a boost bar. So I get it myself. So, presentation area must contain detailed atomic facts. So, now this is a departure from revision 1 of the data warehouse toolkit, where Kimball defined a data warehouse as simply a store of aggregated data. Atomic data was something that might be kept in the staging area, depending on how much space you had available. This was written back when space came at a cost that wasn't always bearable by the business. Disk space is a lot cheaper now, and our ability to process large volumes of data is much greater than it was 15 years ago. So trends have changed, and Ralph is now on the atomic fact bandwagon, where he says, don't just store aggregated data in your data warehouse, store the atomic data. Number 3, dimensions and facts need to be conformed. Okay, and conformed means if 2 things have the same name, then they mean the same thing. Okay. Also, if 2 things mean the same thing, they have the same name. Right? More on confirmation later. All right, dimensional models. We're here, finally. How long did it take? A long time. All right. A dimensional model. Who's heard the term cube before when we're talking about data warehousing? Yeah, excellent. Who knows what it is? All right. Few of you. Okay, much fewer. All right. A cube is an excellent way to visualise how a dimensional model works. Right? We could get a nice throwaway line from our CEO. What sort of business do you do, CEO? And here's a nice line here. We sell products in various markets and measure our performance over time. All right? And this statement contains a lot of things of interest to us. Okay? And I've colour-coded them for you. All right? Aren't I nice? So when we're talking about dimensional models, we're talking about facts and dimensions. All right? Facts are the things that we measure, and our CEO has already told us that we measure performance. Okay? So facts, green; performance, green. Right? Performance is our fact. Performance would involve numbers, usually dollars, not counts of things. All right? Dimensions are the things that describe those facts. All right? The most common dimensions, and you'll see them in almost every data warehouse: customer, location, product, and time. Now, you'll probably see a lot more dimensions than that, but you'll almost always see those 4. And when you're doing a data warehouse project, if you're the dimensional modeller, the first things you should go looking for as soon as you arrive on day 1 are customer, location, product, and time. Okay, if you can't find one of those in the system, ask where it is, because you're probably missing it. Right. So have a look at our cube there. Is that big enough to see right up at the back? You see the little slanty writing? Okay, so imagine it as a cube. We could ask questions. We've got, along the bottom there, we've got our product. I spent a little bit of time in Foster's, and it's a nice, accessible and understandable business model. There you sell beer. So we sell beer, wine, spirits, ready-to-drinks and non-alcoholic drinks, not many of them. Right, we sell them in restaurants and bottle shops and pubs. And we do this over time, we track it over time. So all of these things map back to our CEO's statement there. Right? We can represent this as a multi-dimensional cube. It doesn't always have to be 3-dimensional. Okay? If you've got a good imagination, you can imagine a 4 or 5-dimensional cube. If you're interested in, so what are my sales of spirits for 2011 to restaurants, you can follow those lines to the cube, and you'll end up with one little cubette. Okay, one cell in the cube that will contain the answer or the fact. We've sold 10,000 units of those and we've made $20,000. Okay, did I say spirits? $2 spirits? That's not a lot. Okay, I need to find that restaurant. So, we can also ask questions like, just going across 2 dimensions, we could say, okay, beer at pubs, and then not just pick one element from the other dimension of time. We can pick the entire stream of time, and we can track the sale of beer in pubs over time by taking that strip of data in the cube and plotting it on a graph, if we like. So, this visual representation of a cube as being data is a very powerful way of describing dimensional models to users in a way that they can understand them, and the physical implementation of them is really not that much different. If you imagine the way the data might behave in a physical cube like this, probably behaves much the same way in the computer. All right, dimensional models. So I've described an abstract dimensional model as a cube, and I'm just about to get to the actual physical description of it in a database. But before I do, we'll just go back to those normalised models. What did we say? 300-400 of them in a system. Of all those people that have worked on the operational source systems with 300 or 400 tables, it wasn't always like that, was it? If you got involved at the very beginning of the project, okay, you had a couple of core entities. You had your customer and your invoice and your product, and things are actually looking pretty good because you could print the entire model out on a single A3 sheet, and then it sort of went downhill from there. So whilst we might think of a normalised model, yeah, okay, customer, invoice line, product, yeah, it's all pretty simple. I can join those and I can make that work. The reality is, it's just not like that. This is that diagram there, which is much too small to see now, is a very, very small subset of your average normalised model. They are always this messy. If you try to report off a model like that, you'll run up against 2 things. One of them is complexity. It is so complex, not only can your users not construct good business queries, and remember our queries are changing all the time with a data warehouse. We ask a question once we know the answer to that, we ask a different question. Okay, so we need to start constructing new queries all the time. So we need to understand our data model in order to do that. Normalised model is too complex, you can't do it. Right? The average person can't do it, the average user can't do it, the average programmer can't do it either. You need a lot of experience with a normalised data model to pull that off. The other thing is disastrous performance. If you do actually manage to create a broad-ranging query, something that would cover a big question like profitability on a normalised model, it's not going to perform. You're going to wait weeks for it to come back. Right, dimensional model, on the other hand, that's nice and easy, isn't it? That's a picture of a pretty standard dimensional model. In fact, what have I missed there? Customer, of course. Right, so I've got product, I've got location, I've got date. I didn't put customer on. I may have cut and paste this. So we saw dimensional model represented as a cube on the previous slide. That's in a relational database like Oracle or SQL Server. That's not how it is physically stored. We physically store it in database tables, and we give these database tables 2 different names. We call them facts and dimensions. Okay, the table in the middle there, the daily sales fact, that's a fact table. The dimensions around it, the tables around it, are dimension tables. So every table is either fact table or a dimension table. Remember, we defined facts before as measures. Okay, things that we measure. Right? That's what our fact table contains. It contains the measurements. Right? We defined dimensions before as the things that describe the facts, like customer, like location, like product. All of those things are stored in dimension tables. fact table, dimension table. So before, when we had our cube and we had our list of locations along one axis of that cube, those are the rows in one of those tables, in the location table. Okay, we had another axis of time. Okay, the entries on our time axis of the cube are the rows in the time dimension. The individual cells in the cube are rows in the fact table. It's as simple as that. So if you can understand the cube analogy, it's a very simple step to rows in a fact table and rows in a dimension table. All right, back to vocabulary. Now, I warned you before that Ralph describes data mart in his book, The Data Warehouse Toolkit, slightly differently to the way I've heard it used in the industry. The most common definitions of data mart that I hear are what I'd call a dependent data mart, and that is when you have a gigantic enterprise-wide data warehouse that covers the entire enterprise, right? And then you build another system, not part of that data warehouse, another system off to the side to take the data from one subject area or one business unit from the data warehouse, put that into the data mart, and users query the data mart. They don't query the data warehouse. Okay, that's a dependent data mart. Another definition for data mart that I hear a lot is something that's exactly like what I've described a data warehouse tonight, except smaller. A mini data warehouse that doesn't cover the entire enterprise. It only covers, say, one business unit or one business process, or one group of interested users, typically. So is that consistent with what other people have heard the term data mart used? Yeah, that's pretty common, I think. The data mart is used almost exclusively in the Data Warehouse Toolkit to describe what I call a star schema, that is, a fact table and its associated dimensions. I call them star schemas. Most of the people I've worked with call them star schemas. Ralph calls them a data mart. It leads to a little bit of confusion, but this is a presentation on Kimball ideas, so we're going to call them data marts. I'm going to have to start winding up. All right. In a fact table, one row in the fact table is one measurement in real life, right? So if it is a tick of the cash register at the front of the shop, that is one measurement event, and that equals one row in the fact table. And we don't muck about with that. We don't put a row in the fact table for each tick of the cash register and then put another row in for the total at the bottom of the cash register. That's messing up the grain of our fact table. We like to keep it nice and consistent. Okay. Said before in release 1 of Ralph's book that he described fact tables as containing aggregated facts, and as a result he described the primary key of the fact table, or a key that uniquely identifies a single row, as being a group of the dimensional foreign keys. So if you take, you would have for a product and a customer and a location and a day, if day is the grain of time that we're working with, you would have one and exactly one row. Okay? But now that we're talking atomic facts, he's sort of backed away from that. He says fact tables now contain their own primary key that we allocate when we load the fact in from the source table. Just something that we always do with dimensions. Okay, dimension tables. So in a dimension table, what you're going to see is hopefully a lot of columns, a lot of descriptive columns, because in a data warehouse we want a lot of different ways of describing the same things. We want short descriptions for portrait reports. We want long descriptions for wider reports, landscape reports. We want lots of classification and grouping type attributes in there. The more ways that we can describe our dimensions, the more powerful our data warehouse is. So dimensions tend to have not so many rows. Okay, there are some dimensions that are huge, like if you looked at Coles, for instance, the product dimension of Coles, you'd see hundreds of thousands of individual products in there. Most dimensions are not like that. Okay, they have relatively few rows, but they've got lots of ways of describing them, so they're very, very wide. Okay, in a dimensional table, this is the sort of thing you might see. So every row that comes in from the source system will allocate a unique key to it. All right, that's our product ID. Then we've got different descriptive attributes. We've got a short name for our product, a long name for our product. Then we've got some hierarchical attributes in there. We've got a package type and a brand name. Okay, that package type might be the same for a lot of different products. It's it's hierarchical. Products sit within brand. Products sit within within package types, and we resist the urge to normalise this. We don't take brand and put it in a separate table. We don't take package type, put that in a separate table. That's called snowflaking, and that will get you in trouble with Ralph. Right? We collapse it all down into a single dimension table. This is an example of denormalisation, which if we grew up in an operational source system world, we would know as bad, but in a data warehouse it's good because it makes our queries faster. Last one, their package size. Okay, so sometimes you can have numeric, even though numeric attributes are usually facts, sometimes they're in dimensions. So not all numbers are facts, and not all usually facts are numbers. There's, I actually don't have any good examples of non-numeric facts. Okay, axiom number 2, atomic fact data. I've kind of gone through this already, I think. Old world, we aggregated our facts in the data warehouse. Ralph's now saying, no, keep all your fact data atomic. That doesn't mean you can't create aggregates. You create aggregates for performance, but you must keep your atomic fact data and you must present your atomic fact data. Because when the user drills down to the lowest level of aggregation in their aggregated fact, and they can see that they sold 10,000 units of product X in the northern, to customer Y on January 3rd, they want to go, well, show me the individual transactions that comprise that. That's called drilling through. All right, last axiom, conformed dimensions and facts. So I said before, conforming is if two things have the same name, they mean the same thing. If two things mean the same thing, they have the same name. The most important step, so with facts, that's kind of easy. If we've got a fact called total cost, wherever we see total cost, it means the same thing. Okay, dimensions is much more important because different source systems might have a different idea of some of what we think of as common dimensions, like customer. I mentioned that example before. The delivery system and the ordering system might have their own store of customer data. Okay, if we load customer from the ordering system, we load customer from the delivery system, and we make no attempt to combine them, then all we can answer is order-based queries involving customers and deliveries-based queries involving customers. If you remember the example before where I had a combined data mart, a fulfillment data mart that showed order information combined with deliveries information, if we make no attempt to combine our customer information, then we can't analyse those two facts together. Right? So conforming dimensions allows us to combine different sources of data and to do what we call drill across, is get data from one data mart, get data from another data mart, combine them together. Right, the 4-step dimensional design process, really quickly now because I'm running out of time. You're now the new dimensional modeler in a new data warehouse project. Where do you get started? It's a green field out there. You've got to choose a business process. Right? The business process you choose, you just walk straight up to the CEO or the most senior manager you can find and say, what questions do you ask? What are you interested in? Okay, what decisions do you want to make? Right, and that will tell you. That will give you a very good indication of the business processes that the very first business process that you want to define in your data warehouse. So a process is not the same as a department because processes might cross departments. All right, we declare the grain of our data. Okay, we've selected our business process, like it might be sales, for instance. Okay, so what's the grain of our sales data? Right, if it was supermarkets, then it would be silly to declare the grain as the final sales receipt, because we'd be missing out on those individual products on each line item. It'd be a much smarter choice to pick our grain of the business process that we're covering as the individual line on the cash register receipt. Right? So we choose our grain that we're going to put into our star schema or our data mart, and then we stick to it. Okay, we don't go, oh yes, but there's this other interesting piece of information at a different grain. That's something for a different data mart. Right, step 3, choose the dimension. So once we've found out what we're going to measure, we're going to say, well, our grain is a single line on our receipt. What describes that line? It might be, we might just see $3.55 on there, but the things that describe it are the time of day that it was processed, the product that's been purchased. If you're the sort of supermarket that tracks individual customers, perhaps by loyalty cards, you might know that, and location, the register number in the supermarket where it was sold. These are the things that describe that individual measurement that we've taken. All right, and then we identify the numeric facts. Now on our cash register example, the only really obvious one, two really obvious ones are the price charged and number of items sold if that was if they were grouped on the line. So you might have 2 items costing $2.20, but then you might also have an individual item cost. Right? You might also have some other source of information where you can get where you can pull in the source cost, the supply cost, if you like. Well, we purchased this item wholesale at $1, we sold it at $1.10. Right, so we'll put that dollar on that fact as well. Right? Even though that belongs to, it was sourced from a different business process, the acquisition process, we can bring it all together into the sales process and present it together. All right.
Ross, what about where the object itself that you've chosen to be grain actually changes? Take, for example, an apple that might be nice or might be poisoned, but it can be turned into an apple pie. Are you tracking then the apple or the pie or something else?
You would, I'd say you might find that you're talking about 2 different business processes there. If you're talking about sales, then you might be talking about the apple pie. If you're talking about purchasing, you might be talking about the apple. There are a lot of allusions there to to dwarfs, but I didn't hear an actual dwarf name. So no boost bar for you. So I would say these are both interesting things. You might find that they're a subject for separate data marts, or you might find that you can take the individual costs from your bill of materials, your apple, your short crust pastry, those things, add them all up and put them in as a total cost of acquisition, okay, into the sale fact. Yeah.
I'm thinking about, perhaps in the case of Foster's close to my heart,
Mm-hmm.
the vineyard growers are actually measured and on their performance on whether or not their grapes end up in Grange or in Canungi Hill. But
Okay.
before that, their grapes go through multiple transformations and storage and size and so on. Is that just too complex to have it at one grain, or are you in multiple table land?
You would for the. I think we would go back to step 1. What questions are we trying to answer? What business process are we trying to track? You might find that you have several fact tables there that you could represent in multiple star schemas, and then you could ask questions on one particular grain and then drill across to the other one. So I'm not saying just choose one grain for one star schema. Okay, you might have other star schemas at different grains, and you can drill across between them. You don't have to combine everything into one queryable package. All right, lastly, slowly change dimensions. This is the last section, and I'll try and hurry through it for you. I know we're running late. All right, very important part of data warehousing. What happens when things change? Good example is when a customer moves interstate. Okay, we might be our customer might be living in Victoria. They move to Queensland. What happens to all of their old sales? Okay, if we join their old sales to the customer record, and the customer record says they're living in Queensland, okay, but they weren't living in Queensland at the time that those sales were made, that might affect the way that we understand that data. It might affect the decisions that we're trying to make. We might be trying to trend the sales in a particular range of products over time by region. Okay, and if all of the historic data that sales in Victoria have suddenly all of a sudden moved to Queensland, we'll get false data in our queries. So we need new sales for this customer, reporting as coming from a customer living in Queensland. We need old sales for that customer, reported as sales to a customer living in Victoria. All right. So a few ways that you might go about this. So you go, well, the customer has many addresses, right? Many to one relationship, customer addresses. Okay, customer has many addresses. Okay, I'm a third normal form kind of guy. That seems a fairly logical way of doing it. So that's great when you're just looking at customer and customer address, but all of a sudden, our nice relationship between sale and customer, where one customer has many sales, and we can very easily relate sales to customers by a simple foreign key between those two tables, doesn't hold anymore. It holds for the customer attributes, but not the customer address attributes. We've got no way of defining, or no simple way of defining, this sale was made to this customer at this address. Okay? We would need to, when we're joining those tables in, we would need to apply some date filters in there, and that complicates the simplicity of our star schema. What not to do, number 2. So you go, okay, so you can't have many to one on the customer table. You can't put it in the customer table because when you overwrite it, that's bad as well. Why don't we just stick that piece of information, which is sensitive over time, against the sale itself, right? Because that way, this sale applied to this customer and was made at this address. That makes sense. Right? What if we solved all of our problems that way? How might our fact look? Okay, we'd go from having a nice narrow fact table that was very, very long, millions and millions of rows, with dimension tables that were short, very, very fat, with lots and lots of descriptive attributes, to kind of, well, not the opposite. We'd still have very, very long sales table, but they'd be very, very wide as well. And we might say, yeah, space is cheap, but how long is it going to take to answer queries when we've got to scan all of this data with our computer? Matt, you look like you've got a question there.
Yeah, well, I mean, if you're going to, more of an observation, but if you're going to choose that approach to bloat your facts and bloat your facts and bloat your facts, why not use Excel as your reporting?
You've been talking.
Excellent. So Excel not a dwarf? No. Okay.
No.
All right. What not to do? Number 3, fractured dimension table. Okay. So we can't hang it off customer. We can't put it in the fact table. So let's create another dimension. We'll have a customer dimension. We'll have a customer address dimension. Yeah, that's kind of feasible because customer address is at a different grain to the customer. Customer is 1 row per customer. Address is 1 row per where the customer's lived. You could do that, but extend that logically to all the possible things that could change about all the possible dimensions that we have. We'd end up with a star schema that had like 30 or 40 foreign keys around it instead of 6 or 7 or 10. So that would, although it's kind of a tenable solution, it would make our structure non-intuitive. We'd go looking for customer information in the customer table. Oh, hang on, it's not there. I wonder where it is. It's in one of these other 5 customer tables. And also our fact table would, even though it's not bloating up with all of these address entries, it is bloating up a little bit with all these additional foreign keys that we'd store in there.
And also, the model also makes it hard to actually associate a customer with any of their addresses without going
Right.
by the sales table.
Yeah, so it's hard to answer questions. Well, it's easy to answer questions about sales. It's harder to answer questions about customers. Right. So what you do in this particular case, if it's important to track the history of an old value, we just create an additional row in the customer dimension table. So, and this is a bit non-intuitive for people that are used to operational source systems. We now have 2 rows in that customer table that represent the same customer, an old row and a new row. The old facts in the sales table are connected to the old customer row. The new facts in the sales table are connected to the new row in the customer table. Okay, so we do have to be a little bit careful because there's things that we don't want to track over time, like customer's name, for instance. If they change their name, we're not interested in their old name. Okay, so when we do create that new row in the customer table, if the name changes, we've got to update the name on the old row. But if the address changes, then we leave the old row alone. Okay, and just create a new row. So that example is that way of handling a changing dimension is called a Type 2 slowly changed dimension. Everyone heard of, or anyone heard of slowly changed dimensions? Yeah. Yeah. Okay. Right. There's 3 ways to deal with changing dimensional attributes. One, the way that I said not to do before, is overwrite the row. Sometimes that's acceptable. If we're talking about the customer's name, for instance, we're not interested in the old name, just overwrite the row. Okay, that's fine. It's a way of dealing with it. If that's the functionality that you want, then that's what you do. And we call that Type 1. Type 2 I just described, insert a new row. We're interested in tracking new facts against new attributes, so we insert a new row in the dimension table. That's Type 2. Type 3 you don't see as much of. What we do is we only keep 1 row for the customer, but we'll keep old and new attributes of the customer as separate columns in that row. So that's it's really hard to extend that model, because what if it changes 5 times? I've got to keep on adding new columns to the table. So it's only useful in some very special circumstances. So time, we are 7 o'clock, which I said was going to be the end time. I do have a very quick exercise here where we can go through the 4-dimensional design steps. Understand a number of people have run out of time and have already left. If you're being polite and staying around, this is the last slide. Will be about another 5 minutes talking about this example. And then it'll be open to questions. So if you do need to leave, feel free to go now. So when I designed this slide, I was originally only going to present to DWS consultants. So I chose a case that would that's especially interesting to consultants. So imagine you're working for a mythical professional services company, and you're building a data warehouse. The CEO of this mythical professional services consultancy describes their business as, I'm not going to do the voice. The giggles were from the DWS people. You NAB people won't get that. But our salespeople deal with clients in many different industries, placing consultants across the country at an experience-based hourly rate. Was that? Yep.
Yeah, you're reading off the slide.
Right. I had to put one deliberate one in. Okay, so the four-step process, let's follow it through. So imagining we're working for this, we're building a data warehouse for this professional services consultancy. We need to choose a business process. What sort of business process do you think would be interesting to our professional services consultancy? Things that they want to know more about.
Billable time.
Billable time. A professional consultancy wanting to know about billable time, or in fact timesheets, would we say? Okay, timesheets. That came as a complete surprise to me. I didn't expect you to choose that business process, so I'm unprepared for this one. Okay, so, and once again, you NAB people don't get that. Timesheets they hold a place very, very close to DWS people, not for the reasons you're thinking. Okay, identify the grain of timesheets. What do we? What is one row in our timesheets table?
Person, hour, comment.
Person, number of hours, client, yep. Project within the client, yep.
The actual time slice it's based on, whether it's a week or a month or
Yeah, okay, yeah, so the date, the time that occurred.
Client,
Okay, cool.
activity, hours.
Yep, okay, so lots of good stuff there. So that's the grain. So we're going to say the grain is, we've actually probably skipped ahead to 3 there. Let's express it as one row in the fact table per consultant, project, day. So not that we're talking about DWS here, we're talking about a mythical professional services consultancy. DWS put in timesheets at the day level on projects that belong to clients. So that's a good grain. So the dimensions, we've kind of already covered that. Project, which encompasses a client as well, the consultant themselves, time dimension,
region.
region, excellent. Yep. So region, and yeah, once again, I'll draw a parallel between this mythical company and DWS. DWS have separate P&Ls for each state. Victoria, New South Wales, and Queensland all have separate P&Ls. So each project bills to one of those regions. And sales rep is another good dimension. Yep, excellent. Why did it have to be Andrew that came up with that? Okay, that's great.
Also, while it doesn't apply to DWS, billable and non-billable time.
So, what we're saying is 60 consultants in this room, and it's excellent. So, Tim, look forward to that. All right, and identify the measures. Number of hours. Got anything else?
Project experience.
Sorry?
Experience dollars, you said that.
Okay, number of dollars, so the rate. Yeah?
What activities they are covering or charging for?
That sounds like a dimension. So measures, I'm usually interested in numbers for measures. So I've got number of hours, I've got the rate at which they're charged out at, which is not always the same on a project. One consultant might be billing at one rate one day at a different rate another day. They're all at the high rate, aren't they? Always the high rate. So there was someone...
Utilisation.
Utilisation. Is utilisation more an aggregate measure? Are we talking utilisation at that grain, at the individual timesheet day grain? Or is that something that we might derive at an aggregated grain?
Yeah, possibly.
Yeah. Once we've brought in HR information, perhaps.
I've got a question. You just mentioned aggregated grain, and you skipped a little while ago. You mentioned there's no problem, which I agree with, having multiple star schemas. There's always going to be someone who asks a question about the level of grain you don't have. So why don't we just never identify the grain we need? Just start off with the lowest possible grain, and then build identified grain star schemas on top of that.
Right, so, and that's entirely consistent with the Kimball approach. First you acquire the atomic grain, so the lowest grain that can be acquired from the source systems, and we build aggregated grain star schemas where we can't get the performance we need. So if we've got some defined questions, defined types of questions we want to answer, or defined grains of questions, since we understand that our questions are always changing, that we want to answer, then we may decide to build some aggregated star schemas simply for performance. But they're not answering questions that couldn't be answered by the atomic grain. Does that answer your question?
For the most part. Sorry.
Okay.
Sorry, might be a bit of a dopey question here,
You haven't asked the question yet.
when you've got two different grains, like what I'm thinking of is consultant cost to the mythical consultancy company and their chargeable rate.
Yep.
So, which would probably be on an hourly basis. How do you work in with those two?
Okay, so you're going to have you're not going to acquire all that information from the one source. Good question. So some of this information might come from our HR system. Some of it might come from the timesheet system. I know when I enter my timesheets, I don't enter my rate in there. I just enter the hours in there. Not that I'm saying that the mythical company is DWS. But all of this information might be available from other systems. So whilst we are processing a stream of timesheet data, we might need to acquire some other data, but persist that data at the timesheet grain, if you like, even though it's not acquired at the timesheet grain. So the rate might be, rate would probably be at a completely different grain, it'd be a project consultant type combination, perhaps. And that would all happen in the staging layer. So we acquire our timesheet data, enrich our timesheet data with all of the other information that we might have acquired from other sources, and present that in our timesheet fact. So even though we didn't have that rate at the timesheet grain when we acquired timesheets, we have imported it to that grain, if you like.
Ross, question in regards to this mythical company. You build out at a daily rate, but you put your time in at an hourly rate.
Okay.
On the timesheet. So how does that work?
Well, it doesn't always work like that, does it, Michelle? There's also fixed cost. If you can apply an algorithm to it, then you can apply that algorithm in the staging layer. It doesn't have to be just a straight join of information. And perhaps for some projects, the
transformation in the staging area, or in the
that's in the ETL, the transformation. So
in the transformation.
If you think you can, like if you think that charge out rate would be an interesting fact to put in your timesheet table, and you believe that you've got a business process that supports that. So let's say we can get that piece of information all the time, then the means by which you get it might not be the same for every single project. But if you can codify that rule into if this, then look up that, then you do that in staging, and you never push that sort of rule to the presentation layer. Presentation layer is simply putting facts together, number of hours, charge out rate, and then attaching the dimensions to it. So you do all the heavy lifting in the transformation layer.
Ross, in that case, couldn't you have that in there as two different measures?
Yes, it is two different measures. Yeah, so the hours and the rate.
Or no, as in billable hours, billable days.
Billable days. No, I think we're talking about there. I think you're talking about two different grains. If you're talking about hourly rate and daily rate, then I could see my way to putting those two at the timesheet grain, if you like, because you could do potentially do different calculations on those, but number of.
I'm thinking more of the billing engine rather than the timesheet engine.
Yeah. So there might be there might be another fact there. So we're talking about the timesheet fact. That yes, a billing fact, number of days billed. Yeah, it might be a different star schema.
How do you deal with muddy sources of truth? For example, there's 12 different sources of names for dwarfs.
Yeah, such as
the concept.
Yep. The quality of data that you get out is directly proportional to the effort that you put in. Operational source systems are designed to answer operational questions. They won't have all of the richness of information that you want in there for your data warehouse. So your ETL team, your data warehouse design team, is going to have to put in some effort to enrich that data. Now that enrichment might come through applying heuristics or algorithms to the data to transform it, or it might be acquiring other sources of data to enrich the data that we already have. But if you've got 12 different sources of dwarf names and you make no attempt to resolve them, then you're going to live with a fair bit of pain.
Sorry, if I was designing a fact table for this mythical company, and I find two measures at the same grain and with common dimensions, if I was to put them in the same fact table, would that make you grumpy?
Only if they came from a different measurement process. Okay, so a single row in an atomic fact table should contain the measures for a single measurement. Okay, if it was coincidental that two measures from two different measurements were captured at the same grain, then you probably should. There may be there may be star schemas in your data warehouse where you combine them into the same star, but you should store them separately because, as one of the earlier slides said, change is inevitable in our data warehouse as we respond to new requests for data. This coincidental alignment of dimensions might not persist.
So if you had a sales event and then you put the amount, the raw amount plus the tax, that could work. Whereas
if they come from the same measurement.
The charge rate, if it came from HR system versus the timesheet systems, because it came from two different places.
Oh, okay. Well, it's the charge out rate. I guess it depends on how you define it. If you say the charge out rate for this consultant for the hours that they worked on this project at this client, then it is part of the same measurement. Really, it depends on how you express it.
Ross, clearly this system has overtime built into it.
I'm sorry for running overtime, but I do have 9 more boost bars, and we've gone through all the dwarves, I think. Paul, you've asked a question. I'll come back to you. Just one up the back.
Just in relation to the slides, I've been a bit bashful about asking this type of question.
Oh, no, you only get one.
I may have been sleepy when you mentioned it. Will you be happy to... sorry, sneezy.
That deserves it.
After this session?
So what was the last bit of that? Would I be... The actual question there was...
Are you going to be distributing the slides?
Excellent question, and well done in so many respects. So I'm going to give you 2, not the 7 that you deserve. I'll seek advice on distributing the slides. As you can see from the slides, if you've got excellent eyes, at the bottom of each one was a quoted source. This is a very derivative presentation of Ralph Kimball's book. I go back to to one of the very first slides that I showed. If I have piqued your interest in dimensional modelling, I strongly recommend the Ralph Kimball's book, the Data Warehouse Toolkit on dimensional modelling. Everything that I've talked about tonight is contained therein. So I would need to seek permission for distributing the slide pack. My current position is that I'm not.
Thank you very much. Are you inspired? Do we want to see more of Ross? No.
No, Ross, don't go away. On behalf of National Australia Bank and especially on behalf of Asset Servicing, the team that Ross works in, I'd like to express an enormous amount of gratification. I'm flabbergasted, and I'm not sure whether that's a dimension or a fact. I think it's probably a fact I'm flabbergasted by the 111 enrollees, attendees to this evening. It's a very brave thing to do to stand up in front of 111 of your peers and critique and summarise a seminal work of this nature. And on behalf of everybody, our sincere gratitude and thanks for creating a whole world, and including Shannon Bennett and his restaurant. I hope that you're not building the Sam Newman Cafe, Harry Kafta Wheels version of the data warehouse for asset servicing. However, I know that I was late because I was presenting to some clients about how much we were going to have access to this rich data and how it was going to change our business. And I sincerely believe that, and the passion this man shows is a testament to that dedication and to the team that's building the asset servicing data warehouse. So on behalf of NAB, thank you very much, Ross.
Thank you, Tim.